Everybody's first RAG demo works. You chunk a PDF, embed it, stick it in a vector database, and the model answers questions about it. It feels like magic, and you ship it. And then you point it at 10,000 real documents and it falls apart. It confidently answers from the wrong document. It misses the paragraph that contained the answer, and it cannot handle a question that spans 2 files. And here is the thing nobody tells you. That is not a model problem. Almost every RAG failure is a retrieval failure, and retrieval is a search problem, not an AI problem. The model can only reason over what you handed it. If you hand it the wrong 3 paragraphs, no amount of prompting saves you. So this episode is about the part that actually breaks. 9 concepts, 1 running example. A support assistant answering questions over your company's documentation. And in this bit, we will spend more time on why RAG fails than on how it works, because the how is the easy half. Start with what is actually wrong. A language model knows what was in its training data, and it knows nothing about your company. It does not know your refund policy, your API's rate limits, or what your CTO decided last Tuesday. Ask it and one of 3 things happens. It says it does not know, which is honest and useless. Or it hallucinates something plausible and wrong, which is worse than useless. Or it gives you a generic answer about refund policies in general, which is not an answer. So how do you fix it? Option 1. Put everything in the prompt. That works right up until your documentation is bigger than the context window. And even when it fits, a model given 200 pages reasons far worse than one given the 2 relevant paragraphs, and you pay for every token, every time. Option 2. Fine-tune the model on your documents. And this Option 3, and the right one, do not teach the model anything. Look up the relevant passage at question time, and put it in the prompt. Retrieve, then generate. That is RAG. Concept 1. The 2 halves, and which one you will actually spend your time on. RAG has 2 phases and they run at completely different times. The indexing phase happens offline, before anybody asks anything. You load your documents, split them into chunks, run each chunk through an embedding model to turn it into a vector, and store those vectors. That is your index. Then the query phase happens at question time. The user asks something, you embed their question with the same model, find the chunks whose vectors are closest to it, take the top few, paste them into the prompt with the question, and ask the model to answer using only those. 6 or 7 steps, and none of them are hard. You could build it in an afternoon, and that is exactly why RAG has a reputation for being easy and a reputation for not working. Because look at where the intelligence lives. The model is the last step, and it is the part you did not build. Everything before it, how you chunked, what you embedded, how you searched, what you kept, is a search engine that you built, probably badly, in an afternoon. When your RAG gives a bad answer, the model is almost never at fault. It answered faithfully from the garbage you handed it. Concept 2. Embeddings. What they actually capture and what they miss. An embedding model takes a piece of text and returns a list of numbers. A vector, maybe 768 of them, maybe 1500. And the property that makes it useful is that texts with similar meaning get similar vectors. So how do I reset my password and I forgot my login end up close together, even though they share almost no words? That is the whole trick, and it is why RAG beats keyword search for questions phrased in the user's own words. Now what embeddings are bad at, because this is where people get burned. They are bad at exact matching a product code, an error number, a specific version string. Ask for error 503 and semantic search will cheerfully hand you a chunk about error 502, because those 2 strings mean almost the same thing in embedding space, and they mean completely different things to you. They also compress. A 500-word chunk gets squeezed into 1 vector, and detail is lost. The more you cram into a chunk, the blurrier its vector becomes, until it is a vague average of several topics and close to nothing in particular, and they encode no notion of recency, or authority, or correctness. A wrong document and a right document about the same subject sit right next to each other. The embedding cannot tell you which is true. Concept 3. Chunking, the single biggest lever and the one everyone gets wrong. If I could get you to take one thing from this episode, It is this: your chunking strategy determines your retrieval quality more than your embedding model, more than your vector database, and more than your prompt. And almost everyone uses the default split every 500 characters, which is close to the worst possible option, because it cuts mid-sentence, mid-table, and mid-thought. Think about the failure modes. Chunks too small, the answer is there, but the context is not. The chunk says it expires after 30 days, and the model has no idea what it is, because the sentence naming the subject was in the previous chunk. Chunks too big. One chunk covers 4 different topics, so its vector is a blurry average and it is close to nothing in particular. It never gets retrieved even though it holds the answer. And the killer, a question whose answer spans 2 chunks. Your top K returns chunk 1, which has half the answer, and the model confidently gives you half an answer with no indication that anything is missing. What actually helps? Chunk on structure, not on character count, split on headings, sections, paragraphs, so a chunk is a coherent thought. Overlap them, so a sentence at a boundary appears in both neighbors, and add context to each chunk before you embed it. Prepend the document title and the section heading, so a chunk that says 30 days becomes refund policy, eligibility, 30 days. That's when change. Contextual chunking routinely improves retrieval more than swapping your embedding model. Concept 4. The search itself and the approximation nobody mentions. You have a million chunk vectors and a query vector. Finding the true nearest neighbors means comparing against all million every query, and that is too slow. So every vector database uses approximate nearest neighbor search, HNSW, typically, which builds a graph structure and walks it. It is fast and it is approximate, and that word is doing real work. Your database can and does miss the genuinely closest chunk sometimes. There is a tuning knob trading recall for latency, and most people never touch it and never know it exists. Then there is K, the number of chunks you retrieve. And K is a trade you must make consciously. Too small and you miss the answer. Too large and you flood the context with mostly irrelevant text, which costs money and, more subtly, hurts accuracy. A model given 10 chunks where 1 is relevant does measurably worse than a model given 3 where 1 is relevant. Noise is not free. And one more thing worth knowing, because it explains a lot of confusing behavior. Cosine similarity has no absolute meaning. A score of 0.82 does not mean good. If nothing in your corpus is relevant, the top result still comes back with a respectable-looking score, and your model will faithfully answer from an irrelevant chunk. You need a relevance threshold, and you need the courage to return nothing when nothing is relevant. Concept 5. The fix that most teams skip and shouldn't. Remember that embeddings are bad at exact matches. Well, keyword search, BM25, the algorithm behind Elasticsearch and Lucene and 30 years of search engines, is excellent at exact matches and bad at synonyms and paraphrase. Those two are precisely complementary, so run both and merge the results. That is hybrid search, and it is the single highest leverage upgrade for most real RAG systems, and it is skipped constantly because vector databases are the fashionable part and BM25 is the boring part. Concretely, the user asks about error code 503. Semantic search returns 3 chunks about errors in general. BM25 returns the chunk that literally contains 503. You merge them, usually with reciprocal rank fusion, which is simple and works, and now you have both the exact hit and the contextual ones. Your users search with product names, version numbers, function names, error codes, and acronyms, and every one of those is a case where the embedding is worse than a keyword index. The rule: if your users type identifiers of any kind, you need hybrid search, and you needed it yesterday. Concept 6. The second pass, cheap to add, and it works. Here's a structural problem with everything we have discussed. Your query embedding and your chunk embedding were computed completely independently. The chunk was embedded months ago and had never heard of your question. That is called a bi-encoder, and it is what makes search fast. You can pre-compute everything, but it means the similarity is a coarse approximation of relevance. A cross-encoder is the alternative. It takes the query and the chunk together at the same time and scores how well that specific chunk answers that specific question. It is far more accurate, and far too slow to run against a million chunks. So you do both in sequence. Retrieve 50 candidates with fast vector and keyword search. Cast a wide net, prioritizing recall. Then re-rank those 50 with a cross-encoder and keep the top 5. You have spent a little latency and a little money, and you have dramatically improved what actually reaches the model. This two-stage pattern, cheap wide retrieval, expensive narrow re-ranking, is exactly how every serious search engine has worked for 20 years, and it is the most reliable quality win available in RAG. If your RAG is mediocre and you can only do one thing, add a re-ranker. Concept 7. The last mile, and how to stop it lying. You have your chunks. Now the prompt, and there is more craft here than people expect. Ground it explicitly. Tell the model, answer using only the context provided. If the context does not contain the answer, say you do not know. Without the interrupt, it will have to decode a string data and blend it with your documents. And you will get an amphibase, have your policy, and have the internets with no seam visible. Demand citations. Number your chunks and require the model to cite which one each claim came from. This does two things. It lets a user verify, and it measurably reduces hallucination, because a model that must point at its source is more constrained than one that must not. Watch the ordering. Models attend more strongly to the beginning and end of a long context and weakest in the middle. The lost in the middle effect. So put your best chunk first, not last, and accept that grounding reduces hallucination and does not eliminate it. A model can still misread a chunk, or combine two chunks into a claim neither makes. The citation is what lets a human catch that, which is why I would say citations are not a nice to have. For anything that matters, they are the product. Concept 8. How you know it works, and almost nobody does this. Here is what actually happens in most teams. Someone changes the chunk size, tries 3 questions by hand, decides it seems better, and ships it. That is not engineering, that is vibes. And it is why so many RAG systems plateau at mediocre and stay there. So build an eval set, 30 to 100 real questions with the answer, and this is the part people skip, with the chunk that should have been retrieved. Now you can measure the two halves separately, and that separation is the whole point. Retrieval quality, for each question, was the correct chunk in the top K? That is recall a K, and it is the number that matters most, because if the right chunk never arrived, nothing downstream can save you. Also measure where it ranked, which tells you whether a re-ranker would help. Then generation quality, given the correct context, was the answer right? Was it faithful? Did every claim actually come from the context, or did the model invent something? And now, when your RAG gives a bad answer, you can say which half failed, instead of guessing. In my experience, it is retrieval, roughly 9 times out of 10. Without evals, you will spend a month tuning prompts to fix a chunking bug. Concept 9. When RAG is the wrong tool, and it often is. RAG has become a reflex, and it should not be. 4 cases where it is wrong. 1. The question needs aggregation. How many support tickets mentioned billing last month? Retrieval finds you 5 relevant chunks. It cannot count. That is a database query, not a semantic search, and no amount of RAG will fix it. You want text or SQL, or a proper analytics pipeline. 2. The answer needs the whole document. Summarize this contract. There is no relevant chunk. Every chunk is relevant. Just put the document in the context window. They are large now, and this is a case where the simple thing is correct. 3. You need behavior, not facts. If you want the model to always answer in your company's tone, or always emit a particular JSON shape, RAG cannot do that, because RAG supplies facts. That is a prompt problem or a fine-tuning problem. 4. The corpus is small and static. If you have 20 pages of policy that change twice a year, you do not need a vector database, an embedding pipeline, and a re-ranker. Put the 20 pages in the prompt. You have just deleted an entire subsystem, and it will be more accurate. And the honest summary, which will land well in an interview. RAG is for grounding a model in a large, changing corpus of facts, where you need citations. Use it for that. Let us put it back together. RAG retrieves, then generates, and the retrieval half is where it lives or dies because the model can only reason over what you hand it. Embeddings capture meaning, and they fail at exact matches. They blur long chunks, and they know nothing about which document is correct. Chunking is your biggest lever. Chunk on structure, not character count. Overlap the boundaries and prepend the document and section title before you embed. That one change beats most model upgrades. Vector search is approximate, and cosine scores have no absolute meaning, so you need a threshold and the courage to return nothing. Add BM25 and merge, because your users type error codes and version numbers, and embeddings are bad at those. Retrieve 50, re-rank with a cross encoder, keep 5. That is the most reliable quality win there is. Brown the prompt explicitly, demand citations, and put your best chunk first. Build an eval set that measures retrieval and generation separately, because it is retrieval that failed 9 times in 10. And know what RAG is wrong for counting, for whole document questions, for behavior, and for a corpus that fits in the prompt. Next in this series, AI agents. Subscribe!